Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to chemistry class, chapter 11, organic chemistry. Today, topic under discussions are hydrocarbons, functional groups, their definition, examples, and some common functional groups. Let us start our today's lecture. Hydrocarbons. What are hydrocarbons? Organic compounds that consist of only carbon and hydrogen are called hydrocarbons. Means the compound which consists of only hydrogen and carbon is regarded as hydrocarbon. Basically, this hydrocarbon is derived from hydrogen and carbon. Majority of the organic compounds contain some additional atoms or group of atoms in place of hydrogen that give special property due to that compound. For example, CH4 is hydrocarbon as it consists of only carbon and hydrogen. And other atom or group of atom represented by a Y is added to that hydrocarbon, and finally a product CH3Y is obtained. This CH3Y is obtained by replacing one hydrogen from methane, and finally CH3Y is obtained. This CH3Y has basically two parts. This CH3 part that is called hydrocarbon portion, and this Y portion that is called functional group. This functional group basically impart its special properties to the compound. Let us explain it. Functional group. Functional group could be an atom or group of atoms within a molecule that is responsible for characteristics chemical reactions or its characteristics properties, its special properties. These are regarded as the functional group. Functional group may be single atom like oxygen, nitrogen, sulfur, phosphorus, and group of atom like carboxylic group COOH group, aldehyde group CHO group, and many more. Let's have a look on the common functional groups. First of all, alkene. Alkene is C double bond O. It is a functional group. This C double bond O is regarded as the functional group as it gives special properties to its compound. Its first member is ethene with two carbon atoms and having a double bond in between them. Then alkyne with carbon-carbon triple bond. It is regarded as the ethyne and its formula is C2H2. Alcohol with general formula ROH. Its first member is ethanol with formula CH3CH2OH. Then ether with ROR, that is a single oxygen atom is sandwiched between two alkyl groups. Simplest example of ether is diethyl ether. Then aldehyde. Aldehyde is one carbonyl group. That C double bond O is regarded as carbonyl group, is sandwiched between one alkyl group and one hydrogen atom. Its simplest form or first member is ethanol with formula CH3CHO. Its last have ethanol Al group. The next is ketone. In this, a carbonyl group is sandwiched between two alkyl groups. Simplest member is methyl ethyl ether or dimethyl ketone. Dimethyl ketone or methyl ethyl ketone. The next is carboxylic acid. Carboxylic acid is R C double bond O then OH. This is a carboxylic acid and its simplest member is acetic acid with formula CH3COOH. Then ester, here in ester C double bond O. The CO2 group is sandwiched between two R groups and the final is ethyl acetate, its member, and its formula is CH3CO2CH2CH3. The next is amine. Amine is when N group is bonded to one alkyl group. then it is regarded as the amine. The simplest is ethyl or methyl amine with formula C2H5NH2. Amide. Amide is when a carbonyl group is sandwiched between R and N group, then it is called amide. Its formula is CH3CONH2 and it is regarded as acidic amide. Let us explain these common functional groups, and the first is alkane. Alkane is not regarded as the functional groups as it consists of only carbon and hydrogen, but all functional groups are basically derivatives of alkane. So first of all, we should have a knowledge of alkanes. Alkanes is a group of compound that consists of only carbon and hydrogen. All are single bond. Their name ends at ane, A-N-E-ane. Here it has two carbons, so it is regarded as ethane. One thing more you have to clear over here is that carbon is making only four bonds. Either all are single covalent bond, or maybe one double bond and two single covalent bond, or three double bond or one single covalent bond. Here is some members of alkane families. First is, if carbon is 1, then it is methane. If carbon is 2, then it is ethane. If carbon is 3, then it is propane and its formula is C3H8. If carbon are 4, then it is butane with formula C4H10. And so on. Carbon 5 pentane, carbon 6 hexane, carbon 7 heptane, carbon 8 octane, carbon 9 nonane, and carbon 10 is decane. The next is, as I have told you, all functional groups are basically derived from alkanes by replacing one of its hydrogen atoms. When one hydrogen atom is replaced from alkane, then it becomes alkyl group. Then it becomes alkyl group. That is, the unbranched alkyl group is obtained by removing one hydrogen atom from alkane, and this is regarded as alkyl group. For example, methane. In methane, when hydrogen atom is replaced, it becomes methyl and it is abbreviated by Me. When hydrogen atom is removed from ethane, it becomes ethyl group. That is alkyl group. From propane, when hydrogen atom is replaced, it becomes propyl group. When one hydrogen is replaced from butane, it becomes butyl group, and then one bond is free. In all these alkyl groups, one bond is free, and this one bond can be attached to any functional group. Now this bond is free to be attached with any functional group. Let us see these functional groups one by one. First of all, simplest functional group is alkene. That is, two carbon atoms are making double bond. Their name ends at "ene." Some member of alkenes are, if two carbon atoms are present, then it is ethene with formula C2H4. When three carbon atoms are present, it have given the name of propene with formula C3H6. With four carbon atoms, it becomes butane with formula C4H8. With five carbon atoms, it is pentene. 6 is hexene. Then 7 carbon atoms, it is heptene. With 8 carbon, it becomes octane. With 9 carbon, it becomes nonene. And with 10 carbons, it becomes decene with formula C10H20. The next is alkynes. Alkynes are when two carbon atoms are bonded by three three bonds, that is the triple bond, and their name end at "-ine", Y-N-E-ine, that is ethyne. Its other members are ethyne with two carbon atoms, propyne with three carbon atoms, ब्यूटाइन वन ब्यूटाइन इसको इसलिए कहा गया है क्योंकि कार्बन 1 पे ट्रिपल बॉन्ड है. Then with 5 carbon, it is pentyne. These all have its triple bond at carbon 1, so it is regarded as 1 pentene, 1 hexene, 1 heptine, 1 octine, 1 nonine, and 1 decyne. The next are alcohols. When one hydrogen atom from the alkane is replaced by OH group, then this compound becomes ethanol or alcohol. It has one OH group. It can be classified as primary, secondary, or tertiary according to the position of OH group. It is named as alkanol. The next are haloalkanes. Haloalkanes are when one hydrogen atom is replaced by X group. X are halogens, that is fluorine, chlorine, bromine, iodine. Then this compound becomes haloalkanes, and this is the formula of chloroethane. It is given chloroethane because these two carbon atoms give ethane, and one hydrogen is replaced by chlorine, so it is chloroethane. Next are amines. Amines are when one hydrogen atom is replaced by NH2 group, then it becomes amines. Amines have a group NH2. It may be regarded as primary, secondary, and tertiary. It is given the name of alkyl amines. It is ethyl amine. One more carbon, it becomes propyl amine, butyl amine, pentyl amine, hexyl amine, and so on. Primary amines have basically one nitrogen is bonded to one carbon, only one carbon atom, so it is primary. When this hydrogen is replaced from nitrogen and it is replaced by one mole alkyl group, then it becomes secondary amines. When this hydrogen is also replaced by one more alkyl group, then it becomes tertiary amines. The next are ethers. Ethers are when one oxygen atom is sandwiched between two alkyl groups, then it becomes ether. Ether have name and with ether, like this is ethyl, methyl, ether. The next are aldehydes. Aldehydes are when hydrogen atom is replaced by a group C double bond OH group, then CHO group, then it becomes aldehyde. It is given the name of alkanal. This is the formula of ethanol. Ketone. When carbonyl group C double bond O is sandwiched between two alkyl groups, then it becomes ketone. It is general name is alkanone, and here it is 1 carbon, 2 carbon, 3 carbon, so it is propanone. Propan for 3 carbon and on for ketones. The next is carboxylic acids. When one hydrogen atom is replaced by carboxy group, that is C double bond OH group, then it becomes carboxylic acid. It has one OH group and one carbonyl group. This C double bond OH group is the characteristics of acid group. This is given the name of alkanoic acid. Here it consists of two carbons, so it is given the name of ethanoic acid. Now there is a short video for you people to Here is a short video for you people to show you conversion. First, these are hydrocarbons as it consists of only carbon and hydrogen bonds. As it consists of 3 carbons, so it is propane. It is propane. Now, one hydrogen from this carbon is replaced by an atom Z that is regarded as the functional group. These functional groups may be alcohol, ester, ether, carbonyl compounds, nitro compounds, amides, and so on. First is carboxylic acid. Carboxylic acid is when carbon make 2 bonds with oxygen, 1 bond with OH and 1 bond with R group. Then it is regarded as the carboxylic acids. Carboxylic acids are very important class of organic compounds. Its simplest is formic acid. Formic acid is found in ant stream and in all citrus fruits like lemon. Carboxylic acids are found in B string. Its simplest is when hydrogen is replaced by R. It is found in B string, insect string, in all citrus fruit like lemon, orange, grapes, green apples, and sour milk. The next is alcohols. Alcohols are when hydrocarbons and hydroxyl groups combine together. When one hydrogen is replaced by OH group, then it becomes alcohol. Simplest is methyl alcohol. Then further is ethyl alcohol. It is also given the name of ethanol. It is found in beer and wine. The next are esters. Esters are when carbon is bonded with C double bond O and R group. It is because of esters, all these foods have special type of aroma. Its simplest is ethyl acetate. The next is ether. Ethers are when oxygen is sandwiched between 2 R groups. Simplest is diethyl ether. The next are carbonyl compounds. Carbonyl compounds are when C double bond O is found. It has 2 major classes. Aldehydes, when C double bond O has one H group, then it is aldehyde. It is found in beetroots and almonds. Ketone are when C double bond O is sandwiched between 2 alkyl groups, then it becomes ketone. Ketones are found in mushrooms and strawberries and blueberries. These are some of the functional groups: ketones, aldehyde, formic acids, methanol, ethyl acetate, and diethyl ether. One common thing in all these functional groups are presence of oxygen, that these all functional groups have oxygen. This ketone have C double bond O, aldehyde C double bond O, formic acid has C double bond O, methanol has O group, ethyl acetate have C double bond O as well as COO bond. This carbon oxygen and this carbon oxygen bond. Diethyl ether also have a COC bond between them. These all are oxygen containing functional groups. Next are nitrogen containing functional groups. These are amines, amides, and nitro groups. Amines are found in caffeine and these narcotic drugs. Amines are classified as primary, secondary, and tertiary. When one hydrogen is replaced by alkyl group, then it is primary. When two hydrogens are replaced by two alkyl group, then it is secondary. And when three hydrogen atoms are replaced by three different alkyl groups or same alkyl groups, then it becomes tertiary amines. Primary, secondary, and tertiary amines. It has group NH2, it has NH, and it has simply N group. It is methylamine, it is dimethylamine, and it is trimethylamine. Next are amides. Amides are C double bond O and NH2 groups. It is amide. It is found in DNA and proteins. I hope so you have enjoyed this video. Thank you. Thank you and have a nice day.